So this is what kinematics is all about. How objects move in space and time. So when we say how, this how can be answered by what we call the path. No? The path, so ibig sabihin, in order to answer how objects move in space, we are actually looking for the path. So what is this path? Okay? This path is a curve in what we call space-time. So the path, or in general, we call this is trajectory. No? Trajectory. Trajectory has a higher, has a more profound meaning than the path. The path is just the curve. But when we speak of trajectory, kanisha, we are talking not just the path. This is, we can say that this is the path plus the when. No? So trajectory is not only the curve, but it will, when we speak of trajectory, that means that we know when does the object will pass through that point. So for example, if we have, for example, this could be the path, no? This is the path. But when we speak of trajectory in general, we will take this as a word that would mean, if this is only the path, then you know the particle, mo ni siya this is where the particle will pass through. So you know the road. The problem is that if you do not know the when, okay, so the path is actually the where. The path, or we call this the where. No? So if you know only the where, no, but you do not know in which time, you know that the particle would pass through this point. But when? So, it makes our description now incomplete. And it's almost useless. But in physics, we need to know when and where. That implies that trajectory would give us the location of the particle in every moment in time. So that means that there is a, how do we know now if X represents the where and T represents the when, then that would mean that we will now have the position, okay, or the trajectory in general, the trajectory is just equal to the path and the when and where. X as a function of time. This is X of t, trajectory. Okay? So, basically, where and when is summarized in this function, X as a function of time. Okay? So, this means that this is a mathematical assurance that we can indeed construct a space, just like if you have the line represented by y of x, no, y of x, which is equal to mx plus b. No, this is a y as a function of x. We can actually construct x as a function of time, no? So meaning that here, this will be the time axis, and this will be the x axis. Now, this is one-dimensional motion. So, that would mean that we have now an x versus t axis. And the x versus t axis will tell us the where and when is the particle. And this x of t, this x and t is what we need to analyze, okay? Kinematics. To analyze, because we can just extend this to 2-dimension and 3-dimension easily. Okay? It's the same. Okay? So anyway, so in general, as I've said, in general, we can have x of t, y of t, and z of t. Meaning, x could be the distance, the vertical displacement. Is the vertical displacement. Y is the, I don't know, it could be the horizontal displacement, the vertical displacement, and the, sa bana dire. Whatever is the ano ninyo sa kuan. So in general, you have this. But for now, we just need x of t. One-dimensional lang sa ta. So for example, suppose that this is that one. There. This is x1, t1, and x2, x2, t2. That would mean that, okay, okay, the particle at t, okay, first, we call this t here as the coordinate time. No? Every point in the xt axis, now in the xt plane, okay, is what we call the coordinate time. This is the zero is actually arbitrary. We can set that zero any time. But we are in general in physics, what we are actually most interested in is not the coordinate time. In kinematics, it's not the coordinate time, but the elapsed time. Okay? So the coordinate time here is this is the coordinate time dire. Okay, maybe I'll just, okay, this is important. This one here is what we call the coordinate time. Okay? Every point here is a coordinate time. Okay? But this one here, the difference is what we call delta t, which is what this is now the elapsed time. This is the time that we feel. This is the time that, the time that we perceive, the elapsed time. So basically, coordinate time is arbitrary. I can set my zero now, or I can set the zero, the time zero, when we started, the moment that I entered into the classroom. That would be the time zero, or I can start my zero now. But the difference between the lesson, like for example, this portion of the lecture, whether I set the start of the time, the moment that I entered the classroom, or the moment I started writing, the time that the running time that we're discussing this part here doesn't change. It's the same. Why? Because here's the difference. Delta t is just t1, t2 minus t1, no? Where delta t is equal to t2 minus t1. So the coordinate time is the clock, the ticks of the clock. This one here is the distance covered. This is now delta x. So that means if we're going to make a physical sense of this graph, no? Think of T1 as, maybe we can think of this as, let's say, 1 o'clock, and T2 as 3 o'clock. No? In the road, di ba namin makita nga kilometer 14, kilometer 100, right? And that's as far as I know, that's actually, they said that it's the distance from Luneta. That's kilometer 0. No? So for example, this could be kilometer 100, and this could be kilometer 180. No? So you are at kilometer 100 and, at 1 o'clock, and you are at kilometer 180 at 3 o'clock. No? Okay. So, by the way, we have the trajectory. This t here, what does this t stand for? Is it the coordinate time or the elapsed time? The t here. Huh? No, this is the coordinate time. And this one here is the coordinate space. We can think of this, if this is the coordinate time, then we can think of this as the coordinate space. Right? It's a location. For example, if this is kilometer 100, no? KM 100, KM 100, no? Is just a location, a specific point. No? Well, you can, of course, when you have KM 100, then that means that you have KM 0000. But again, that 00 is arbitrary. We can set the 0 anywhere. But in general, setting the 0 anywhere doesn't change the distance covered, right? Doesn't change delta x. Okay? Whether you put the 0 here or you put the 0 there or anywhere here, it doesn't change the length of the distance covered, right? And although we have this function here, no, what we are actually interested in to make sense of the physical world is not the coordinate space and it's not the coordinate time, because these are just locations and like time in our clock. No? What the physics is actually all about the distance covered and the elapsed time. No? That's the activity, that's the event. No, that's the event that we are trying to describe. Okay. Now, okay, balik ta diri sa ko ano. Okay. Okay, we have two definitions here. Velocity, and of course the unit of this is meters per second. This is also will be meters per second. If this is in meters here and this is in seconds, then this would both be meters per second. Velocity and speed, this is not the difference. The speed is the distance covered divided by the elapsed time. Now, what's the distance covered? The distance covered is always positive. No, it's always what we call the absolute value between the how far you have walked, no? So that's the distance covered. For example, this is an example. Like you go into this, mubalik ka dire, no? Point 1 and point 2. The length of this curve is the distance covered, right? How about the change in position? In this case, the change in position is 0, right? So that's the difference. In fact, you will have here a positive speed. The speed is always positive because distance covered is always positive. But the velocity on this one is 0, right? Why? Because what's the change in position? After, let's say you travel this by an elapsed time of delta t, no? Whatever is the time. So in this case, the speed for this case, for this path here would be, well, it could be just the length, the arc length dire, no? This is S. Let's just call this C. So S is equal to C over the elapsed time, no? Delta t. How about the velocity? The velocity would be 0. Why? Because the change in position is, the position did not change, no? No, it's just, this is final minus initial. Okay, the position did not change. So the net velocity there is 0. Now, can we say that the speed is always greater than the velocity? Can we say that? No? We can actually claim here, no, we can claim now that the speed, okay, the speed is always greater than or equal to the absolute value of the velocity. The speed is always greater than or equal to the absolute value of the velocity. In fact, I showed you the case that in this situation here, the speed would be a positive number. No, it could be a very large positive number, or it could be a small positive number, but the velocity in this case would be 0. Okay? But of course, how about when you evaluate the time at this point here? So mulahi na siya karon, right? Let's go in the, let's suppose that we evaluate the time, the elapsed time up to that point. Now, of course, the velocity here will no longer be 0. But note that the distance covered is still greater than this. This is only the change in position, right? So which one is greater? This curve here, the velocity would be measured, would be this length here. No? Let's call this C and let's call this L. No? The speed now, okay, speed would just be equal to C over delta T. They both have the same delta T, right? Because, kana siya. Sabay sila ni, the travel time. How about the velocity? This is L over delta T. And we know that C is greater than L, right? That's why you have speed is always greater than or equal the absolute value of the velocity. The velocity can be negative, right? That's why I put the absolute value here. That's why I put the absolute value, because the velocity can be negative. This displacement, it's no longer distance but displacement. Okay? We can think of the change in position as displacement. No? Another term for this is displacement. That's the change in position, no? So just L over T. Okay? Okay, by the way, let's have these two trajectory A, B, and C. Which is faster? Which is the fastest? Which one is the fastest? Okay, so the fastest is A, no? Why? Because A, okay, I think we have okay, ato sa ningin ko ano? I'll add a fourth nga kwan. Let's call this D. This trajectory, this is car D. Now car D and car C would end on the same X, right? So that means that if this is car D and car D and car C would end in the same X. Okay? So let's call this S. SA is the speed of A, of car A, and SB will be the, okay, speed of course, no? So on, no? So you have now SB, SC, and SD, the corresponding speeds of the other three cars. Now, which is the fastest? Which car is the fastest? Which car is the fastest? Well, look at the formula. We are now just looking at the speed. It's the distance covered and the elapsed time. To increase the speed, you have to increase the distance covered, right? Or maybe the same distance covered but lesser elapsed time. In this case, you have two cars, car A and car B have the same distance covered, right? So which is faster? A or B? They have the same distance covered, right? They have the same delta X, tama? No, they started here and they both ended here. So, they have the same distance covered, but A has a what? Has smaller elapsed time. So that means that SA is greater than SB. Tama? So SA is greater than SB. How about D and C? Again, both have the same distance covered, right? No, D moves from here hantud dire na, right? And C also moved from this place to that place there. But the elapsed time of D is much. No, this is the elapsed time of D. Here, A and D have the same elapsed time, right? No, for A and D only traveled for this amount of time here, no? But B and C travel for this time. Nakuha? Okay? So, we can call this as delta T1 and this is delta T2. And we know that delta T2 is greater than delta T1. Now, kumbaga pa, A and D, only, think of this as simultaneous, they left this point here. Now, A and D reached their destination at the same time. But they have different destinations. A traveled much further, right, than D. Whereas B and C, although B has the same destination as A, and C has the same destination as D, but they arrived much later than the two, right? At the same time also, B and C arrive at their destination at the same instant, no? When B reached this point here, C has also reached this point here, right? At exactly the same time. They left at exactly the same time, no? And B reached this point the moment that C reached this point here, right? Also the same with A and D. A, we can now see that A is faster than B. Also, well, we know that SD is greater than SC, right? SD is, okay, car D travels much faster than SC. Okay? How about A and D? A is certainly travels faster than SD. Although they have the same elapsed time, but A has a greater distance. So, we can say also that SA is greater than SD. No? How about B and C? From here, we can conclude that SD is greater than SC. SB is greater than SC. Why? Well, they have the same they have the same time of travel, but car B had traveled a farther distance. Nakuha? So that's why SB. Now, how about this claim here? Can we claim SB is faster, equal, or less than SD? Okay? Because we have some sort of uncertainty here. SA is faster than SB, SD is faster than SC. And SB is faster than SC. SA is faster than SD. How about SB and D? Which among the three conditions, no? Greater than, equal, or less than? Can we assert this? And the answer is no. We cannot know. We can only know if they have values, no? But in general, if they don't have values, we cannot establish which one is faster, B or D. Nakuha? Why? Why is that? Because for the reason that although D had a smaller time, but B had a farther distance. Nakuha ninyo? So although smaller time siya, which is also a requirement that the speed would increase. Whether you increase the distance covered, you travel much farther with the same elapsed time, or travel at the same distance, no? But at a lower time. Okay? So duha ka condition. Now here, B has much farther distance, traveled has much farther distance than D. No? B has traveled much farther distance than D. But D has traveled quicker, no? Quicker, has D, on the other hand, has a little time, has smaller time of travel than D. So, in fact, because of that, we could not establish this one. This is a known. How about A and C? Well, it's obvious we can easily say that A is greater than C. Well, this is very certain. In fact, we can say that if we give order here, we have SA, and then we have SA is greater than SC. No? Here, it could be this could be SD or this could be SD here. No? The two can interchange dire. Or even we can take this as equal. So, what we are certain, what we are very, D and can interchange here, B and D. Okay? So, no? Now, okay, we have here this is a trajectory of the particle, no? Let's take this as a trajectory of the particle. Particle from point A to point B, it takes what? This is time, x, tx man na siya, no? Right? By the way, this is so meaning our point here is given in terms of tx, right? Let's use this convention, meaning that this is time and this is x, no? So, meaning, it took 5 seconds for, okay? Sabtan? So, let's calculate the distance, no? The distance, what are the distances here? Distances. We have XAB, right? XAB, which is what? XA minus XB. Okay? XA minus XB. How about, and then we have XBC, which is XB minus by the way, this is XB minus XA. Okay, this is XC minus XB. Well, we know that this is what? This is 5, no? 5 minus 0, this is 5 meters. This is XB minus XC, this is 5 minus 5, this is 0 meters. It has not moved. Okay? How about XC to D? This is XD minus XC. So that would be 10 minus 5. So 10 minus 5, that would be 5 meters. X DE would be, okay, this is 8, this is XE minus XD would be 8 minus 10, right? 8 minus 10. Okay, since we are talking about distances, we take the absolute value, right? Okay, but okay, for now, ato na siyang i-absolute value, no? Distance man, right? Because this is distances. This is 2 meters. Okay, by the way, I'd like to change this distance. Sorry, let's just change this to D, no? DAB, DBC, DCD, because I'd like to use X for the displacement. Okay, so let's just use D here. So D, X gihapon, no? But let's put absolute values dire, no? Nakuha. Okay? Because I'm using, yeah. Okay? So how about DEF? This is DF minus DE, absolute value. This is 0 minus 8, right? Absolute value, and this is now 8 meters. Now, how about the displacements? These are the distance covered, no, from point to point. How about the displacements? Or the change in position, no? The displacement. Okay, let's call XAB, which is still XB minus XA. Still, we have this 5 meters, right? And again, x, b, c would be, okay, para makatipid tag kuan di ato sang ato lang ikuan dire. Okay, we have x, a, b, which is x, b minus x, a, that would be 5 meters, right? And x, b, c, still we have 0 meters. X, c, d, okay, c to d, that's 10 minus 5, the same dito. Again, the same here, but we don't take the absolute value, right? So this would be 5 meters. Now the difference now would be x DE would be what? Negative 2 meters. And x EF would be negative 8 meters. No? From here, we can calculate speeds and velocities. Now, let's use S for speed and V for velocity. Okay? So, that means that SAB would just be DAB over the elapsed time, no? Let's call this delta T, TAB. What's delta TAB? This would be 5 minus 0, tama? Okay? So this would be, again, 5 meters divided by 5 seconds. Okay? This would be 1 meter per second. Okay? How about VAB? This is XAB over still delta TAB. That would be, again, 5 meters over 5 seconds. And this is still 1 meters per second. Okay, now, look at the velocity. The velocity is described to be delta x over delta t. So, that means that if you have in space-time, you have this point 1 and point 2, where this one is delta x, and this one is delta t, looking into the line, we can, into the geometry of the line, we can say that the velocity is just the slope of the line connecting the points, right? So, okay, the velocity is just the slope of the line connecting the points, the terminal points. We call these terminal points, no? These are terminal points, no? Let's call these points terminal points A, B, C, D. So what's the velocity then? The velocity is defined as, the velocity is just the slope of the line connecting the terminal points, the two terminal points. Nakuha? No? It's the slope of the line connecting the two terminal points. So I'd like, okay. I'd like to note that one here. No? Velocity is the slope connecting the slope of the line, the slope of the line connecting the two terminal points. Terminal points. Okay? Like this one. If you have point 1 and point 2, the slope of that was the slope delta y over delta x, right? In the Cartesian plane. So in this case, our delta our x is t and x is y. So you have delta x over delta t. Okay? Now you can calculate SAB, SBC to be what? 0. So is XAB. Okay? And Well, this looks boring apart, but later, when we get into the jumps, there is the interesting part. I'll show you later. SBC, XBC. And, okay, the CD, how about SCD? This is 5 meters, this is what? So how about CD? That's SCD is DCD, 5 meters, divided by what's the elapsed time? CD. The elapsed time is 14 minus 12. That's just 2 seconds, right? 2 seconds. So this is now 2.5 meters per second. And since this is also equal to XAB. Now, here is the difference. How about SDE? SDE is, okay, 2 meters divided by, what's the elapsed time? 15 minus 14. So this is 1 second. So this is 2 meters per second. But XDE would give us what? Would give us XDE, which is negative 2. This is negative 2 meters per second. This is 2 over 1 second. So you will have negative 2 meters per second. So how do we interpret these two differences? Meaning that in this case, XDE, we are now traveling at 2 meters per second towards the, well, if this is up, then on the downward direction, right? And also you have SEF would be 8 over 20 minus 15, that's 5, right? So pila ni siya? 8 over 5, that's 1.6 meters per second. But XEF would be negative 8 over 5. That would be negative 1.6 meters per second. Okay? Now, here's the catch now. Here's the interesting part. How about the SAE? And what is VAE? Okay, this is SAE is basically, this is DAE over, but, okay, this is misleading here because DAE is not, we have to, we have to put our frame in the car that move, or somebody, in the particle that moves in this case, no? DAE, okay, so for now, this is delta TAE. What's DAE? DAE is a sum. Okay? DAE is DAB plus DBC plus DCD plus DDE, right? That's DAE. No? Over delta TAE. What's delta TAE? Well, delta TAE is kani. This delta TE minus delta A. Right? This is the elapsed time. So it's just delta, this is TE minus TA. Right? And you will see that this is 5 plus what? 0 plus 5 plus 2 over 15 minus 0. Okay? So this is 5 plus 5. This is 12 over 15, right? 12 over 15. Or this is 0.8 meters per second. Okay, what does it mean by DAE in this case? DAE. DAE is the total distance covered, okay, from point A to point E. Now, again, the distance is path dependent. Just like katong ganiya gyano atong curve, remember the curve? It's path dependent. It depends on the path. No? So meaning, there are many ways to arrive at E from point A. And in this case, in our case, we are actually taking this trajectory into our context. That's why we have to add this, all of this. This is what we call an average speed. Okay? We can say that this is our average speed. Average what? Average from point A to point E. Why? Because in going from point A to point E, we have gone through many changes. Right? Now, we now calculate the average velocity. This is the average speed and the average velocity. And we will interpret what's the difference between the average speed and the average velocity. No? This is XE minus XA. Velocity does not depend on the path, but only depends on the final state. This is just final minus initial. So TE minus TA, that would be what? 8 meters. Right? XE is 8 minus 0 over, this is 15 seconds. So this is, pila? 0.5, exact. 53 meters per second. And clearly here, you can say that VAF equals 0, right? Because this is 0 minus 0. And while SAEF is, no, that's not 0. That's DAB plus DBC plus DCD plus DDE plus sana, no? So that would be 5 plus 0 plus 5. This is 20. So 20 meters divided by, what's the elapsed time? 20 seconds. So this would give us 1 meter per second. Now, this is the fundamental difference of the average velocity and average speed. Suppose you want to go to Davao City, or I think must busy dito CDO. So let's go to CDO because it's the road here is much busier than the road to Davao City. So let's take the road to Cagayan de Oro City. In fact, if you let's say, I know, what's the distance between Musuan to CDO? Let's just use 160, no? Kilometers. Let's use 160 kilometers. From here to CDO, no? Let's say 160. Suppose you left at 7 o'clock in the morning and reach CDO at what? Let's say 11 o'clock. No, so what's the average speed? What's the average speed? Okay, ato ni siyang kana no. This is murag mo ni Mindanao, no? Mindanao. Here we are, this is CDO. So the road is like this, no? Murag ana. So the travel is, the distance from here to CDO is, let's say, 160 kilometers. Or just 100 kilometers na lang, no? 160. 160 kilometers. And then you start at 7 o'clock, you arrive there at 11, so 4 hours. So what's your average speed? That would be 160 divided by 4, 40 kilometers per hour. But how about the average velocity? The average velocity is this distance here. And if this is 160, we can think this might just be 80, right? Okay, daghan man ka nag-curve. So that our average velocity is just what? That's 4 hours, 80 kilometers divided by 4. That would only give us what? 80 divided by 4. 20, right? 20 kilometers per hour. And by 4 o'clock, balik na po ka, no? Balik ka, you will have a zero average velocity, right? Later on. But not an average, zero average speed. No? It could be that pagbalik nimo ni hawa na po kag 11 o'clock, let's say nanghihira ka dito nang kaon kag Jollibee. You went to Jollibee and eat, and then by 11 o'clock and then 3 o'clock balik na po ka dire. Exactly the same. So what's the average speed? That would be you traveled 160 plus 160, 320 divided by 8. Still, you get 40 kilometers per hour. But the average velocity would be, that would be zero in the afternoon, by 3 o'clock in the afternoon, because you arrive at the same, I mean, you have come back to the same initial point. But here's the thing here. Kung tanawon man gud ninyo, what would matter is the average speed. Because the average velocity is of no use to us, because this distance is of no use to us, right? We are not traveling in this distance. We are traveling this road here. So the average velocity doesn't matter here. What matters actually is the average speed in this case. So how does this apply to us? Going from here to kung tanawon ninyo you have many stops from here to Cagayan de Oro. Okay, if you travel to CDO for 4 hours, 100 kilometers for 4 hours, no? You have an average speed of 40 kilometers per hour. But does that mean that you are constantly traveling at 40 kilometers per hour? No. Right? No. It doesn't mean. In fact, at times you are traveling at 80, maybe 100 or maybe 120, and there are times that there are traffic lights, no? Pag-abot ni mag-Valencia na traffic lights, or maybe na kuan dito, the flow of traffic is slow, no? So just like in this case, this could be a traffic here, no? From B to C, posible ni siyang na-traffic, no? Because it doesn't move. It only moves in time. By the way, a purely horizontal path is impossible. That means that suddenly you appear on a different position, tama? With the same time, no? It's like something that vanishes here and appears here in no time, right? So this is impossible. And the steeper it becomes, the faster is the velocity. The greater is the velocity, right? The greater is the velocity or the speed, no? the steeper it becomes. Okay. So it doesn't mean that you are traveling constantly at 40. Only that after 4 hours you have traveled 160 kilometers, just like our example here. No, the total time divided by ano. Now, what is this to us? Well, there are lots of people that drives you drive me crazy, no? I mean, crazy drivers. Why? If you travel, suppose that your fastest, suppose that you set to yourself that, okay, I'm only going to travel as at most 70 kilometers per hour, or maybe 60 kilometers per hour. Is it possible that I would reach CDO in 4 hours? Of course, yes. Why? Because the average is 40, right? And in 40, traveling at 60 kilometers per hour is very possible to reach CDO by 60 within 4 hours. Now, there are drivers who actually drives at speeds of 120, 140. But the problem is that in the roads here in the Philippines, this is not the road here is national highway, not an expressway. It's different from NLEX and SLEX in Luzon because expressways, no, expressways are separated from pedestrian. Muna expressway. They're separated from pedestrians. Walay cross, walay mo cross di ang ano. Tanang all the flow of traffic is on the going and paana dito. They are actually on separated. Separate ang padulong o separate ang pabalik. You can sure ka nga wala kay mabanggaan. You can travel as fast as you want. But here in Mindanao, we have no expressway. In Visayas, we have one in Cebu, CCLEX. Okay? The Cebu-Cordoba Expressway. But here in Mindanao, we don't have an expressway. We only have national highways. National highways are as highways. Highways meaning kaning kuan. These are fast highway, no, traveling from one city to another. We only have that. And in many cases, these roads are the traffic flow here. There are times where the traffic flow is kumbaga pa smooth, no, light, no, you can travel fast. But maybe 30% of the time, the traffic is just heavy. Or maybe it's impossible for you, even if your car can travel up to 400 kilometers per hour, it's just impossible to use that. So, kaning mga kaskasero nga driver, no, they actually try to, they kumbaga pa, murag sagaro nila. But knowing that even if you travel at 120 kilometers per hour, you could not travel. Maybe you can only use that 3 to 5 seconds, 10 seconds as most. Why? Because after some time, naana po kay katagbo, after some time, naana po ano dito, and after some time, ano na po ng traffic. Meaning that traveling at 120 would only give you very small amount of time to use that speed. But the problem is that when you travel at that speed, even though bisan pag 10 seconds na, you're putting your life in danger. So, maybe if you travel, kung paspasero ka nga driver, no, you travel at 120, 80, 90, at least 70, you will arrive at CDO, or maybe in your destination, the CDO by only 3.5 hours. Whereas katong driver nga, mo travel lang og 60, arrive there in 4 hours. Now the question is here, this. Is 30 minutes difference worthy to, is the 30 minutes difference worthy to risk your life and the life of your family or your passenger? That's always the question. Walang ginaano na ako, no? Like, if you're a driver driving towards those, what matters most is the average speed. Yes, pwede ka makatipid og time. And in 4 hours travel, maybe makatipid ka og time nga 30 minutes. The question always is that the 30 minutes nga imuhang natipid dito, is it worth it? Because in order para makatipid ka atong 30 minutes, you have to drive at times by 120, 80, 90, 100 kilometers per hour. No? So meaning it doesn't make a large difference if you travel like 60, no, if you limit your speed up to 60, compared to the person, this is the point. No, there's not much difference. There's not much difference. No, there's not much difference for the time of travel for the person who limits himself at 60 kilometers per hour to a person who can actually goes even up to 120 kilometers per hour. No, maybe 30 minutes, the person who goes up to 120 can arrive 30 minutes earlier. But the point is that 30 minutes, is it worth it? Is it worth it to risk your life? Because when you travel at 120 kilometers per hour, not in an expressway, in just a highway, you can risk your life, you can risk others' life also. No? Pwede ka kabangga, or even animals' life. No? Igo, nagbaka diya. So that's always the case there. Because what would matter in the end is the average speed. Muna pero may ginasulti ginaw sa family na mingo sa papa nga nganong moabot man ka sa manghod, nganong moabot mo 100, 120. It doesn't make sense that you travel, you murag maabot kag 120 But you can only use that speed for only 30, I mean, maybe at most 10 seconds. After 10 seconds, so may ano, you have to slow down. Why? Because naana po ka sa crowded area. Unlike in this expressway nga, ano gid siya? Straight, no? If you travel by 120, pwede ka dito mo 120 tibok straight. Wala man tayo expressway diri.